Okay, in this video we're going to talk about Unit 2, Objective 5, which are trig rules. There's not a lot to the trig rules other than you just need to have your trig rules memorized. So here are the 6 trig rules for derivatives. When you see on here d dx sine of x, that just means the derivative of sine of x. Sine of x is our function. So the derivative of sine of x is cosine x. The derivative of tangent x is secant squared x. The derivative of secant x is secant x times tangent x. Derivatives of cosine is negative sine. Derivative of cotangent, negative cosecant squared. And the derivative of cosecant is negative cosecant cotangent. So you're looking at 6 rules, but if you look closely, there's really only 3 rules that you need to memorize. And then you can look at your cofunctions as being the opposites. So if we look at sine, derivative is cosine. The cofunction for sine is cosine, so its derivative would be negative sine. If you look at tangent, tangent's derivative is secant squared. So if we think about cotangent, it's going to be a negative cosecant squared. If we look at secant, it's secant tangent. Think about cosecant, it's negative cosecant cotangent. So when you're doing your cofunctions, meaning they start with cosine, cotangent, cosecant, all of your cofunctions have negative derivatives, and they are very, very closely related to your functions over here. So sine, cosine, cosine, negative sine. Tangent is secant squared, so cotangent negative cosecant squared. Secant is secant times tangent, so cosecant is negative cosecant times cotangent. You need to have those rules memorized. All 6 of them, all 6 show up on AP quite frequently. Now, granted, sine, cosine, and tangent are the 3 that show up a little bit more frequently than the other ones, but AP has asked in the past and will continue to ask about cotangent, cosecant, and secant. So we need to go a little bit farther than just sine, cosine, and tangent. We need to know all 6 of these. The tricky part with trig is not the derivatives themselves, but the fact that trig will almost 100% of the time be a chain rule problem. And there's 2 ways that we can see it, so we'll look at an example of both and then we'll call it quits on the video. The first way we might see it is if we have something like f of x is equal to sine of 3x plus 4. So if we think about the functions that we just had on the previous slide, if we look at them again, the derivatives are just for sine of x, tangent of x, secant of x, cosine of x, cotangent of x, cosecant of x. Those are just the very basic trig functions. AP will hardly ever ask about a basic run-of-the-mill trig function. If you notice the one we have on the screen now, it's sine of not just x, but 3x plus 4. So if you think about the last video, if you think about the previous objective, you think about chain rule, we said chain rule is going to happen when we see parentheses. Well, when we look at trig, we have sine, and then if you look, we have the parentheses around the 3x plus 4. So that's going to mean we need to use chain rule. So our outside function for our chain rule is actually sine, and then the inside part of our function is going to be that 3x plus 4. So trig is almost 100% of the time going to be chain rule. So if we take the derivative of this with chain rule, so f prime of x, remember chain rule, take the derivative of the outside piece first, so the derivative of sine is cosine. Keep the inside the same, right? Only peel away one layer of your derivative at a time. So that's the derivative of the outside part. Now we need to take the derivative of the inside. The inside function is that black part at the top, the 3x plus 4, so the derivative of that is 3. And then to make it simplified a little bit, we just move that 3 out front. So we would say 3 cosine of 3x plus 4 is the derivative of sine of 3x plus 4. So chain rule is going to show up in that function, in that matter, when we have sine of something, cosine of something other than just x. The other way that we can see chain rule within trig is a little bit more tricky. If we have something like f of x equals tangent squared of, we'll go 5x to the third plus 7. So when we look at this, there's really 3 layers to this derivative. And the tricky layer, the one that we're not going to see easily at first, is this layer right here. That squared gets its own layer. So whenever we have a trig function that has a square or a cube or anything, I want us to rewrite the function in the following manner. I want us to think like this. Tangent of 5x cubed plus 7 squared. So we kind of want to move that square out to the outside so we can kind of see our layers a little bit better. And once we get used to this, once we see them enough, we won't have to do it every time. But it's easier now to see that, okay, I have a set of parentheses here. So I have this blue layer is squared. Then we can make a green layer inside that. So the green layer would be the tangent part. And then inside of that, we have a third layer, which would be our 5x cubed plus 7. So when we go to start taking our derivative, piece by piece, we have to do the blue part first, so take the 2, drop it down front. Then we have tangent stays the same. 5x cubed plus 7 stays the same. Take the derivative of the next piece, so the next piece would be that green part. Remember, working outside in, peel one layer at a time. Derivative of tangent is secant squared. Keep the inside the same. Then we get to the inside part, the red part, the red derivative would be 15x squared. And then we simplify. So we have a 2 out front and a 15x squared, so that's going to give us f prime of x is 30x squared tangent of 5x cubed plus 7 secant squared of 5x cubed plus 7. So the 2 main ways we're going to see our trig derivatives almost exclusively are going to have chain rule. First way is going to look like this, where it's just a function, sine, cosine, tangent, whatever, with an angle that's not just x. So in this case it was 3x plus 4. Or we're going to see it like this, where we have a squared or a cubed with our trig function. And again, for the first few times we do these, I want to pull out that exponent so we can see its own layer. And then we just build or chip away from the outside in. So those are your trig rules. Make sure you know all 6, and that'll do it for this video.